All right. Take it away, Scott.
Okay, let me get the screen sharing working. Is that coming through okay?
Yep.
Awesome. And get the clicker. So yeah, thanks for having me. Today I'll be talking about dependency freshness measures and what that means. Let me just got to rearrange my windows so I know what's coming next. There we go. Yeah, so hi, I'm Scott, and I love to fix bugs, like genuinely love to fix bugs, like not just a little bit, but a whole bunch. So much so that was like one of the big reasons for creating Corgibytes was to just focus on fixing bugs. And then also like any other kind of maintenance activities, such as like upgrading dependencies. But upgrading dependencies is an interesting one because while I really like doing this, and for years, I thought that it was kind of important. I didn't really like push any of our clients too heavily on this. I figured that, you know, they would upgrade when they were ready, or if there was a security vulnerability that had been like, was really scary, then it would get taken care of. Or if something was painful to use, then we would go ahead and talk about upgrading. But for the most part, I didn't really push anybody about it. And then, whoops. And then this event happened. So Equifax's massive data breach. But what I thought was really fascinating about this wasn't necessarily that Equifax had a mass data breach. I feel like that was probably, I feel like with most systems, it's inevitable to have some kind of data breach. But for me, what I thought was really interesting was that it was a 2-month-old bug in a dependency that caused the vulnerability, that could cause the breach. So it was Apache struts, and it had been fixed for 2 months, but they hadn't upgraded yet. And like, I always work from the assumption that everyone's doing their best. The teams that are working on systems like this, they're doing their absolute best. And so I started to try to think like systemically, what would cause this to happen? And when I kind of look at like why I didn't upgrade dependencies, you know, because again, I talked about how I didn't always upgrade them, and then why other people might not either. Fear was always a big factor, like specifically fear of a bug, and fear of introducing a bug and having that be like, you know, upgrading the dependency being what introduces a bug, even though I'm doing it to try to avoid a bug. Usually there's a new version of a dependency because a security vulnerability has been fixed, or there is, new, less buggy behavior that's out that I want to take advantage of. There's also time, like sometimes upgrading these dependencies is non-trivial. There are breaking changes, and the time to do that is often seen as less important than other things that the team is focusing on. And that kind of comes into like what, just mixing priorities, like different activities there's only so much of us to go around on a team, and we have to pick and choose what we're going to work on. And the perceived difficulty, it's actually perceived to be, pretty difficult to do. And it's an invisible problem. It's something that, is kind of hides under the covers. It is not something that's obvious. It's definitely just kind of lurking, and then it eventually kind of comes out of nowhere and bites us, kind of like it did for the Equifax team. So I started thinking about like, how can we make this problem that is currently invisible? How do we make it more visible? And I stumbled across this concept of dependency freshness, and it was coined in a couple of papers by Joel Cox and others as a way to kind of describe and quantify how out of date your dependencies are. The idea being that the more fresh your dependencies are, the closer to the most recent versions you are. So, and I think like this as a metaphor, it works pretty well. And I've started thinking of it in terms of like, it's kind of like brushing your teeth, with the goal being that we eventually want to get to MINTY fresh software. And this is kind of where the metaphor kind of works well, is that like, the longer it's been since you last brushed your teeth, the less fresh your breath is. So like the longer it's been since you upgraded your dependencies, the less fresh they are. And you don't have to brush your teeth every hour. Just like you don't have to upgrade your dependencies every hour. But there probably is a good point where like it would be a good idea to do it at a regular cadence, kind of like we brush our teeth once or twice a day, or after every meal. There's some kind of triggering event that like with regularity, brushing our teeth is something we just do. And I think like upgrading dependencies is something that we could get into that same habit of. But just like with brushing your teeth, having dependencies that are out of date can have consequences. But the consequences differ depending on whether or not you're a developer on a team. So for developers, the set of difficulties is, that you end up with software systems that are difficult to work with. So as the dependencies age, it's harder and harder to work with the system. It's harder to find documentation. Anyone who's ever worked on an older Angular app has experienced this firsthand, where they go to try to research how to do something in Angular, and they keep finding blog posts about how to do it with a version that's newer than the version that they're running on, or lots of other insert any other technology. I feel like with Angular, that's definitely one that's bit me before. And then that really kind of falls into like general support is lacking. So community support for things that are falling further and further behind is more and more difficult. So as a developer, having something that's older just really starts to slow you down. And then on the organization side, so kind of like not the developers, but the kind of the organization as a whole, developer productivity is lessened for all the reasons we just mentioned. But there's also a significantly increased security risk because as dependencies get older, then there's the chance that there's a vulnerability in the version you're using is higher. And you end up with the risk of public relations fallout or loss of customer trust, which I think if we look at the Equifax story, they definitely got some bad press around that. So kind of avoiding that is ideal. So one way to make the problem more visible is to use a metric. And so one of the metrics that I stumbled on is called LibYear. And I think this little comic is a great way to describe LibYear. And this is from their website. But the idea is that it's just a metric to kind of help you kind of compare and contrast different projects for, how bad is this project in terms of how out of date it is? Well, it's this many LibYears behind, yeah. So why LibYear? Out of all the different ways that we could measure this problem, why LibYear? Well, it turns out it's very easy to compute, and it's easy, and it distills down the dependency risk into just a single number. So you end up having just like one number that you're able to communicate, and it can provide even more value when you graph it over time. So I think that's something that's pretty fascinating, is that you can kind of, because it's a single value, you can graph it. So how do we measure it? Well, if you wanted to do this manually, you can. And you just take the release date for the latest version and the release date for the version you're on, subtract the two in terms of years, and that's the LibYear for any particular package in your system. And then to get the project LibYear, you just add them all together. So it's definitely something that kind of scales with the number of packages that you're depending on. And the more packages you have, the higher your LibYear score will tend to be. So there are tools out there to help you measure this in an automated way, because who has time to with pen and paper look up when things were released and measure it that way? That's what computers are for. So here's a Python project that will do that for you. And there are lots of other language-specific libraries as well that can compute this metric for you. This is just one. And we can take a look at what that tool looks like when you run it up against PySpider, which is a Python web crawling app. And here it shows you, like, for each of the dependencies that PySpider depends on, the version it's currently depending on, the latest version, and then how many LibYears behind that package is, and then it gives you a total for the library. So, but what if we wanted to measure the changes, like the LibYear as it changes over time? That's a tool. There's a tool for that I'm currently working on building. It's called Freshly. Kind of like, fresh libraries, dependency freshness, kind of playing around with that a little bit. Right now it's open sourced on GitHub. We don't have it currently launched anywhere yet. We're close, but working on that. Definitely a work in progress. So I can show you the same project, PySpider, graphed with Freshly. And this is showing you the max LibYear over time for that project. So you can see how the team started out doing pretty well. And I've got like the recommendation line here at a year. So like the idea being that you don't want any one package to be more than a year out of date. And you can see here that they eventually got to a point where they had one package that was more than 7 years out of date. So definitely good to know. And you're like, well, which package was that? You can dive in and look and see exactly which package kind of caused that behavior. In this case, it's the Jinja 2 package that's up there at the top. That if they upgraded that, it would help them a little bit, but not too much, because you can see there's another one right behind it. You can also see from this graph that there were a lot of packages kind of all upgraded at one time. And if we think about what was going on in the Python ecosystem at that time, late 2019, early 2020, Python 2.7 has been deprecated and is like officially reached its end of life. It won't receive any updates anymore. And so that definitely created a lot of pressure in the ecosystem for a lot of packages to either drop support for 2.7 or add support for 3x. And so that's definitely creating more pressure on people who depend on different Python libraries. And I'm pretty sure that's the reason why all these packages got upgraded, but I haven't actually dug in and like looked at each individual one to see if that's why. That's just my guess based on what I know about the ecosystem. Here's another example using a Ruby on Rails based RSS reader called Feedbin. Here we have the max LibYear over time. And here we can see that the team has definitely like made efforts to pull it down. And they definitely pulled the max down quite a bit relatively recently, but it's kind of starting to skew back up again. And at the same time, they've kind of always been at that state where one library was at least 2 years out of date. And so that's something it just tells you a little bit about team behavior and, whether or not you want to change. This project has a lot more dependencies, so this graph is way more messy. But you can zoom in and try to get a more picture. So this is like the most recent. So like, what is the most out of date package at this point? And on that project, it's Elasticsearch. And so if they brought that down, then it would pull their max down a little bit. So the future for Freshly is to really kind of like explore this dependency freshness space and really achieve a mission of creating tools that can clearly illustrate the financial risk of deferring software maintenance, with the vision being that Freshly won't be needed anymore one day, that teams will recognize that it's possible to automatically upgrade dependencies. And so they'll just create tooling to just do this for you automatically. So automatically detect that a new version of something is available, and then automatically upgrade it, automatically deploy it. That is the tools to do that exist already. And we just need to, start trusting those tools and start leveraging them. So best next steps for Freshly, one of the things I want to do is I want to develop a metric that takes security risk into account. So right now we're just looking at like how out of date you are. But I think it would also be interesting to know like how risky your out of dateness is. So how many known security vulnerabilities are there in the version that you have, or does the version you're using currently have security vulnerabilities that are published? I think that's additional data that would be really useful and help help with prioritizing which packages to upgrade first. And I think that would be really interesting to graph as well. I also would like to be able to formulate ways to better compare LibYear across projects. So kind of the LibYear.com way of looking at LibYear is to just, kind of sum up LibYear and kind of you get this one quantified value for a project. The graphs I showed that Freshlios are producing, in addition to producing that kind of composite score, we're also looking at other things such as the max. And noticing that's probably that's a better way to kind of communicate how out of date something is. But it doesn't tell the whole story. Just, so you can have like 100 packages that are 1 year out of date and your max would be 1, but that still kind of communicates that like you've got a lot that's out of date. So I do think the two work well together. But it really kind of comes into like trying to come up with some good guidance, some good values by looking at existing projects and trying to figure out like, is this team doing a good job? If it is, then what values do they have? And kind of using that as a benchmark or as a baseline for the rest of the industry. If you're interested to get involved, you can head on over to GitHub and take a peek at the project. Ways that you could help would be to add more metrics, such as other dependency freshness measures. There are some in the paper that I referenced earlier by Joel Cox that I'd like to get implemented, and then also something that looks at security. I'd like to support more ecosystems and dependency formats. Right now, there's support for Ruby via Bundler, PHP via Composer, Python via requirements.txt file, and Perl via CPAN file. So I'm currently working on NPM support, and it'll be nice to add support for .NET ecosystem and Java ecosystem, as well as any others that might have any kind of dependency manager that we can get this data out of. Improving the graph quality. I think there's lots of better ways to kind of graph this information. So that's one of the things that we'll be working on. And if you only walk away with like one thing from today, I'd just like you to keep in mind that like auto upgrading your dependencies is achievable. The tools for that are out there. That's a different talk on as far as how to achieve that. But I think measuring your progress towards it over time is a good first step towards getting there. So thanks a bunch. That's what I got. If you'd like to follow along with me, here's how to get in touch and contact. And I'm open to questions.
Hey, this is Kurt. I have a question immediately. It really stuck out in your list is it's very it's like current supported tools. It's dev language centric, but this approach also is very applicable to something like a Docker based ecosystem. Have you thought about applying this to Docker?
I have not thought about applying to the Docker, but that would. But you're thinking like like a Docker image that's using like apt under the covers, and then like looking at how out of date those packages are.
Yeah, that's right.
Like,
well, also just like the base image it comes from. So I mean, you've got the base image you can get the information from, all the apt or Yum operations it's doing. You can introspect the Docker file if you have access to it to see, and maybe it probably is not as easy as looking at. Not probably. It's definitely not as easy as looking at the requirements text file, but the information is theoretically there. Let me say that.
Yeah. No, I like that. I like that a lot. I know that Snyk, Snyk.io, SYNK, they have some tools that will check for security vulnerabilities, and they have support for Docker images. So they'll tell you that like this Docker image has packages that have vulnerabilities, and it will even let you know whether or not there's a newer base image that addresses it. But yeah, it would be neat to kind of talk about like a quantified metric around that instead of just you have vulnerabilities, but just kind of measuring how far out of date you are. I like that.
Your approach is totally applicable to that kind of situation. And the other thing, when you mentioned weighting security vulnerabilities, have you looked at the CVSS scores? like, super simple, perhaps naive approach would be take the CVSS score and multiply it by the age of the, okay, so there's going to be CVSS scores for any intervening. So like you might have do you know anything about the CVSS scores?
That's like the critical, is that what you're talking about? Like for like a CVE,
Right.
that's a scoring system for the CVEs. Is that right?
Right.
Okay.
So there may not be CVSS scores for a lot of stuff. I don't know. That would be a question. You could take, you could be like, all right, I'm on version 1 of this library and version 2 is out and there's CVSSs against version 1 and altogether they total, 15 or whatever.
Yeah. Yeah, that'd be cool.
Idea.
That'd be really cool.
I do kind of like the idea that this is based on a number that you can quantify, even if that number ultimately doesn't mean anything specifically. It's just, something to guide you by. But a lot of times it is really hard to picture. Like we have a bunch of applications that we're building. They're all relatively similar size, because we use same frameworks and stuff like that. But it's kind of nice sometimes to say, hey, this one's being kept up a little bit better. This one is not, right? This one needs more care right now. This one, we're going to need to get to it eventually, but it's in better shape right now.
Yeah, I can see that being useful in terms of like supply chain as well. So like if you're evaluating, do I use package A versus package B? Looking at how well that package has been managing to its upstream, to its dependencies. That you're adopted when you adopt that package as a dependency, you're also adopting all of its dependencies. Kind of transitively. So knowing how well it's been doing it, that I think would be useful in terms of like thinking about your dependency ecosystem as a supply chain.
Yeah, Sonatype does a lot. They do the state of the DevOps supply chain, software supply chain report each year, and they've done a lot of studies on like how often people upgrade, whether it's corporately backed open source that gets upgraded more often, or personally. Someone's just pet projects, if they're big, if they're small. The answer is none of them. Some people upgrade very quickly on big projects. Some people upgrade very quickly on small projects. Some people never upgrade, even if they have corporate support doing it. It's somebody's day job.
Yeah.
It was all over the place. They couldn't find correlations, which actually was good information, but they do a lot on it. And there's actually, if you look through their state of software supply chain, I bet there's a lot you could do to get a number. If you had a number like this to go into it, because like I said, I love the idea that you can compare. I also like just that you could trend a project. One of the things we use in a lot of projects is SonarQube. And one of the neat things sometimes is just looking at the graphs go up or down, right? Depending on which one is supposed to be going. The absolute value is almost never of direct importance, because on a big program, you'll have a lot more bugs than on a small program.
Yep.
That's finding, and the bugs could be serious. They could be just stylistic. Somebody likes putting an extra blank line at the end of the file and all of a sudden, blows up the numbers. But being able to look like, hey, we're working on cleaning this up, and that number is trending down, right? In the case of LibYear, hey, we're bringing our max down, we're bringing our total down. That seems like it would be good information for a team that just wants to know that, hey, we're heading in the right direction. We're not making things worse. Things are generally getting better in what we're doing.
Yeah.
So,
I hate to like monopolize this occurred again. Wondering also, how do you detect when, library X has been out for 3 years, and they've been on version 0.2, and they're like, all right, cool. Well, it's that age is not going up because they haven't released anything. But wait a minute, they haven't released anything. It's gone stale, and do you?
Yeah, I think that's a weakness of LibYear.
Like that?
Yeah, that's a weakness of this metric. Yeah, is that it doesn't take that into account. I would hope that any security like the security vulnerability metric that I'm currently like working on tweaking the final bits of would be like looking at is there like kind of like two components. One would be how out of date are you? And the other is like, how far in the past are you? So that like, if there was a vulnerability and like, even though you might be on the latest version, that version still has a vulnerability and it's 3 years old. So it's like 3 years that someone could have developed a script to attack that vulnerability. Then, you know, that's a higher risk than something that's just a few weeks.
Yeah.
So, yeah. Thanks a bunch for having me, and I appreciate it.
Thank you very much. Any other questions for Scott? All right. Well, why don't we go ahead and let Valerie get started, and then we'll do some more Q&A.
Great. Thank you, Scott. And sorry, I click start video. Here we go. There I am. And thanks, Jean, for having me. And I'll go ahead and try to present here. Okay, does everyone see my slide? Awesome. Okay, so let's get rolling. I am Valerie, as I mentioned at the beginning. I'm a software engineer at Heroku. I work on the data infrastructure team, so all of your Heroku managed data services is our team. My Twitter handle is Valerie Codes, and it's at the bottom of every slide. So feel free to tweet at me, follow me on Twitter. I've got to say, I haven't been tweeting a ton about software lately, but there are a lot of pictures of my dog. So if you like that, I can promise that I will deliver. So today I want to talk about fear. And I want to talk about the ways in which we experience fear and uncertainty. I want to talk about talent and the ways in which we imagine it in our peers and ourselves, and how none of these problems are new or unique to the software industry. This talk is entitled Code and Fear because it was heavily inspired by the book Art and Fear, and I'll be using quotes from Art and Fear to illustrate a lot of these points. So we're going to be discussing talent, art, and software development. First, I'll talk about the parallels between art and code, and then we'll see what we can extract from that to think about the ways that we do our jobs and the code that we write. I really like to have GIF breaks, so here's the first one. And let's get started. My parents are both in the art world. My father is a photographer and my mother was a museum curator before she retired a few years ago. I think they always harbored a hope that I would grow up to be an artist, and as a teenager, they got me this book called Art and Fear, and it's about the day-to-day life of being an artist. It talks a lot about the process, the frustration, and the doubts of making art. And in typical teenager fashion, I didn't read it. I ignored their advice and became a software developer instead. In terms of rebellion, it was honestly pretty mild, but 2 years ago, I happened to pick up this book again. And in reading through it, after working a few years as a developer, I found its message resonant to the world of programming as well. We'll be taking a look at some quotes from the book and how they apply in our work. Some of you may recognize this view, maybe from a desktop background or something. This is Yosemite, and this picture was taken a few miles from the house where I grew up. I spent a lot of time around artists, and one of the authors of Art and Fear took this photo and is a friend of my parents. Art, creativity, and inspiration were frequent topics of conversation in my household as a child. But it wasn't something that I thought had anything to do with computers. After all, computers are predictable, reasonable, and logical. To be honest, that's probably why studying computer science never really occurred to me. So what does art have to do with programming? Before I discovered programming, I thought I would be a type of artist, specifically a writer. Programming always seemed too dry or scientific for me. But it turns out programming involves a lot of creativity. Two people's approach to any given problem may be completely different. And to be a good developer requires technical expertise as well as creative problem solving. I think that we owe it to ourselves as developers to think about that aspect of our jobs more. It's not just about gathering technical requirements, it's about finding a way to fit them all together without making a mess. And programming is a creative pursuit at its core. It requires an understanding of the constraints of our tools, as well as an imagination for how those tools can be combined to meet an end. You're not a machine in which specs go in and programs come out. You're an individual who brings their own process, preference, and biases to everything that you do. And you're in no way interchangeable with another programmer. Many of the aspects of programming and developer culture that people find toxic boil down to an inability to grasp this fact. By dismissing a text editor, language, framework, or process, you're ignoring the fact that other programmers' processes are not your own. Their preferences and thoughts are not based in objective truth, and neither are yours. I just like this one a lot. What's the squirrel in the background? I don't know. Anyway, art isn't easy. In the same way that the work of an artist is often idealized and chalked up to short bursts of energy or genius, many people think great software is created by single lone wolf geniuses over the course of a manic weekend. To a lot of people, software development is that scene in the movie The Social Network where Mark Zuckerberg builds Facebook in a frenzied night of Red Bull and Emacs, and the rest is just marketing. While in fact, software development is a process of fits and starts, of gradual development and rewrites, of trying to fit these disparate pieces together without really knowing if it will work. Like art, software doesn't arrive in our heads fully formed. It takes work to refine an idea into execution, even if the execution at the time we first think of an idea seems clear. Like art, the role of inspiration in writing software is overstated, as there's a long road from an inspiration to a finished product. Like art, software development involves translation of ideas into action and an eventual result. The idea may be more or less nebulous, anything from change the color of this button, to send an email when someone fills out this form, to create a product that will make $1 million. The more refined the idea in the first place, the less divergent different executions might be, but there's always some degree of the unknown in what your code will look like or do exactly until it's done. Here's a comic that encapsulates this feeling from the art side. It's from Tiny Snake Comics. A lot of art making is a struggle. You might hit a flow state every now and again, but most of the time you're just plugging away. So why is it so hard? Making art provides uncomfortably accurate feedback about the gap that inevitably exists between what you intended to do and what you did. The process is hard because things don't actually fit together as well as we want. We've all had the experience of taking on something that seems very clear and straightforward, only to realize as we try to implement it that it is neither as clear nor as straightforward as we initially believed. It's a natural part of being a programmer or really any kind of creative worker that your end results do not always match your ambitions. The hope is that as time goes on, you'll become better accustomed to what is possible and what you're capable of, such that the software that you imagine is closer informed to the software that you write. But even so, the most perfect version of something is always going to be the version in your head. This is sort of the programming equivalent of that earlier comic. As with art, our code never turns out as clean or well-structured as we imagine it in our heads. In software more so than art, it's easier to blame this on external constraints. We tell ourselves that the systems have been set up in ways that make it impossible to achieve what we've set out to do as simply as we would like to do it. But it's also true that we have a tendency to underestimate the complexity of tasks. We feel this about systems that we ourselves have set up. Even given the desire to achieve simplicity and a good understanding of our parameters, the results often feel cobbled together. As we imagine our programs in their best forms, we imagine all the things we know to be possible in their best possible configuration. We also tend to underestimate the constraints of the tools that we work with, the time that we have, and the scale that we need to achieve. There are many considerations at work in making software, and elegance and beauty are generally not high on the list. As satisfying as it may be to write or read beautiful code, constraints of time, data, or existing systems can make it difficult or impossible. In an industry that prides itself on abstractions, abstractions are hard to see when you're searching for the most straightforward path from point A to point B. Writing efficient code can sometimes mean writing less readable or clear code. It's more straightforward to loop over all possible permutations than to build a hash table and perform more efficient lookups against it. Many of the tools that make our programs faster make them less intuitive, and deadlines mean that we often don't have the time to be writing beautiful code in the first place. Yeah, Seymour's been sitting in my lap the entire time. He's just not always visible on the camera. I've given an example here of two methods that should produce the exact same results. Both will return double the integer passed into them. The first uses your typical multiplication method, and the second uses a bitwise operator to shift the bits of the integer one space to the left, in effect multiplying it by 2. But most people would have to look up what that means and what this operator is actually doing. So while it might be faster on a computational level, it's slower on a human level. So which are you optimizing for? The answer may be different depending on your context, but it's worth thinking about. With every choice that we make in code, we're shutting off other possibilities. Part of the difficulty of programming is coming to terms with those decreasing possibilities and realizing that no solution we envision is exactly suited to our needs. All the tools we're working with, existing code bases, programming language, frameworks, and even the code that we ourselves write, is a product of humans with their own constraints of time, imagination, and ability. Most of the skill involved in programming is not in avoiding these trade-offs, but in learning how to efficiently evaluate them and avoid making decisions that will lose you development time in the future due to the need to backtrack. One example often comes up early in the life cycle of an application, and that's how you're going to structure your data. What does your schema look like? There's no single right answer. Maybe you want to be able to do lookups really quickly on a certain field. Maybe that field doesn't matter as much. Maybe you want to use a relational database. Maybe you want to use a NoSQL type database. But that decision that you make early on makes a choice about some things that are going to be both possible and impossible in the scope of your application. The sheer number of these types of decisions in the beginning of a project gives a good explanation why it's often so hard to get started. Do you want to be able to add fields on the fly? Do you want the querying ability of a relational system? Are you worried about constraints of locking or scale? These are important in your development process as much as the choice of, say, materials is important in art. To all viewers but yourself, what matters is the product, the finished artwork. To you and you alone, what matters is the process. Our users don't care about the process of building software. They don't care about what our code looks like or how that code came to be. Understandably, they care about how well our software works. Yet the process of building is important to us and our teammates. You might wonder why. After all, you can delete the spec folder from a project or use tabs instead of spaces, and the code will function exactly as it did before. Even people who see your code won't care when you started work in the morning or the temperature of your coffee when you were writing it. But our process matters because it affects whether we produce good work that we're proud of. And you may find that your teammates find your code more readable when you spend a few hours sketching out the architecture on a whiteboard before putting fingers to keys, or that your code is more effective when you write your tests first, or that you simply enjoy writing code in the morning and reviewing it in the afternoon. Pay attention to these things. How you write code is not important to the outside world, but it's important to identify what makes you the happiest and most effective. You'll probably recognize this top example as a Hello World program in Ruby. The second example is written in a programming language called Cheese++. It's a programming language in which all the commands are related to cheese. As you'll notice, the begin and end keywords are cheese and no cheese. These two programs produce the exact same output, so there's really no reason to prefer one over the other, right? So who is it that really cares? You do. You care that your code is readable. So does your team. Deleting your spec folder doesn't change the functioning of the code you've already got, but it makes it much harder to add or change anything without accidentally toppling the whole house of cards. We choose languages like Ruby not only because they're suited to our programming needs, but because they make us happy. Matt, one of the creators of Ruby, has famously talked about how Ruby was designed with the idea of optimizing developer happiness. He said, I emphasize feeling, in particular, how I feel using Ruby. This seems reasonable, given that a computer doesn't care what language you're writing in, and a user doesn't care what language software is written in as long as it works as intended. Even if it doesn't work as intended, those faults are more likely to be attributed to you, the author of the software, than the language in which it is written. So choosing tools with which you're adept and comfortable becomes even more important. As much fun as Cheese++ is in a demo, writing anything of substance in it would be incredibly arduous because the keywords are arbitrary names of cheese, and there are no libraries or third-party code for you to draw from. Sometimes the code that you write is only for you, but you may not know that as you're writing it. You make good work by, among other things, making lots of work that isn't very good and gradually weeding out the parts that aren't good, the parts that aren't yours. One of my biggest fears as a developer used to be deleting code, because I thought if I worked on code for hours and deleted it, I was just wasting my time. Luckily, I managed to get a little better about this over time, but I still need to be reminded. Most of the code that I write is not good code, but writing bad code is part of the process. Writing bad code is the way that I get my ideas out there. Then I refactor. Sometimes I write or prototype something to get an idea of an approach and end up deleting it and starting again. In the same way that tests are a part of the process that are invisible to your end users, these iterations are both invisible in the end product and critical to its eventual formation. The process of refactoring allows us to take a step back from our code, look at how to simplify it, and improve it. On a more macro level, code is temporary. Let the code that you've written teach you about the code that you want to write. Find ways to make each thing you create, each job you take, closer to yourself. This is how I imagine Kermit the Frog writes code on a typewriter. A lot of code that gets written is the same. Maybe not literally character by character, but we are by and large repeating patterns that we've made before, variations on a theme. I've created this very trivial example where only one of the many lines on the screen is actually doing anything new or exciting. No matter how novel or innovative your application, there's a certain amount of boilerplate that's necessary. You need to be able to initialize your objects, manipulate your objects to interact with each other, with other parts of the application. A lot of this work is necessary, but feels more like translation than innovation. Some of this is for the sake of bookkeeping, and some of it has to do with the fact that a lot of the things we want to do with software are similar to each other in a lot of ways. It can be hard to feel creative in this paradigm. The code that you're proud of is probably a very small subset of the code that you write. And as we think about the code that we write and how we feel about it, we may begin to dwell on the idea of talent. The idea that true programmers must be proud of everything they write, and that a failure to come up with elegant solutions is an inherent quality within us, rather than a product of our skills and constraints at a given time. Over the long run, the people with the interesting answers are those who ask the interesting questions. The topic of talent and genius is ever present in both art and software. We hear about ninja developers or 10x developers. Imposter syndrome is especially common among software developers as with artists, so this is important. Even though it's a waste of time and energy, we can get caught up in these conflicts with ourselves, which can only prevent us from focusing on our work and creating great things. The best we can do is reassure each other, remembering that others' strengths and constraints are their own. And focusing on others' talent is at best a distraction, as it does nothing to make us better. If you're lucky, your career will involve tackling a series of unknowns. And anytime you get comfortable with one thing, you'll have to move on with something else. The best skill you have to bring is not expertise, it's curiosity. So ask questions and don't worry if you don't have the answers. When you think of other programmers' talents or genius or innate abilities, you don't know anything about the steps that it took to get there. Here's some insight into my process that you wouldn't see in a finished product. You serve as an example to your peers of how that process may look on an individual basis, but lots of the time that you spend during a day is not likely to be accounted for in lines of code that are merged into a production application. You may spend lots of time deleting and tweaking lines to see what happens. You may spend time tweaking CSS rules and Chrome dev tools. You may spend hours whiteboarding, user testing, or taking notes. None of this is shown in a final product, but it doesn't mean it doesn't count in whatever psychic sense that implies. It's just a reminder that a finished application is only the tip of an iceberg of insight into what it actually took to make that thing. How this time is spent depends a lot on you and your preferences, and that's likely to inform your code in ways that you can't predict. All art is autobiographical. This is more evident in art than code, but we bring ourselves to our work whether we mean to or not. All of the code that you write is related to the code that you've written before, and the code that you didn't write. Think about how your life informs your work, and how that can help you and the developers you work with. Think about the experiences you've had in your life and how it informs the project that you work on. You're probably more likely to work on code that solves problems you're familiar with and have context for. We won't go too far into this because it could be its own talk, but it's important to consider as we think about how the technology field looks, how the world looks, and who technology helps and harms. Whether we like it or not, personal experiences inform all of our lives as developers. And by understanding each other's contexts, we can better communicate, which makes us better at writing software. I think about the word legacy and how it's perceived in both software and art. Legacy code is something that we fear. But even if your code doesn't survive, that doesn't mean you can't leave your own legacy. Think about what that legacy is. I want to leave you with this thought. Your job is to develop an imagination of the possible. Software is capable of doing a lot more than it currently does. As a developer, you've been given tools to work with that can drastically change people's lives. Software can inspire, empower, and educate, and those tools are yours to wield. Not having the same skills and experiences as those who came before you can only work to your advantage. So make something that could only ever be made by you. And that's all. Thank you again for having me. Again, I'm Valerie Woolard. You can find me on Twitter as Valerie Codes. Feel free to drop me a line if you have comments or questions on this talk, or if you just want to see what I'm up to. And enjoy the rest of your evening. And I can hang around and answer questions now as well.
Thank you very much. A lot of what you were saying actually reminds me, I had to look it up. There's a Michelangelo quote about being a sculptor, that the statue is already in whatever rock or everything they're using. He just has to take the rest away. A lot of the stuff you were saying fit with that, I thought. But I thought that was really good. There were a lot of pieces. I have to go back and watch it again now because there were a lot of quotes I wanted to take out of that. But I do like I get exactly what you had said. That's one of the ones I have to go back. But you said it's about putting things together without making a mess.
Yeah.
Yeah. One of the things you talked about like when you were talking about like different materials and kind of like the material as a metaphor, I've often thought that like material was what made software like not quite so similar to engineering as we kind of want it to be, because we end up inventing our materials and our, so much. And I feel like that, like, for me, like your talk really sparked that like a lot of what we're doing is kind of inventing color and inventing material and inventing process. And that kind of itself is the art in what we do.
Yeah, and it's also like we're creating the things that we're then manipulating.
Yeah.
So like it's sort of this, all of these man-made things built on each other. It's not like you have to learn to work with wood. It's that you're, working with this thing that came out of somebody else's brain.
Right. Yeah.
That was cool.
Hi, can you guys hear me?
Yep.
Yeah, sorry, I came in a bit late, but I did follow the entire presentation. I'm Michael. This is my first time joining. Thank you for the presentation. I liked it. I have one question though. Where does writing code that is maintainable fit into all this talk? Because as we all probably know, there's usually you usually have people saying, no, the code has to be written in such a way that it's maintainable, it's testable, it's all that. How does that fit into this talk you're giving? Thank you.
Yeah, I think that like that's part of your goal as a software engineer. And like if you think about visual artists, maybe if you're thinking about an artist working alone, they don't have to worry about that. But I think that collaboration is also a big part of a lot of art as well. If you think about, what it takes to make a movie or these big creative enterprises, I think you can think of code in kind of the same way, or like a software product in kind of the same way, where you're not just working on your own little part in your own isolated little universe. You're having to think about all of the other moving pieces that go into that. And part of that is, in making code that's easy to manipulate and easy to edit for the next person that comes along.
Yeah, they always assume that the person who's going to edit your code after you is going to be a homicidal maniac that has your home address, and that may be you.
Yep.
Hey, this is Kurt chiming in again. Nice slides, by the way. Good apropos video. So I wanted to, you had mentioned something about deleting code being hard. I wanted to just chime in on it immediately. I thought about how it got easier for me to delete code once, I started getting really comfortable with tools like Git. Because it's like, oh, I'm not really deleting it. I'm just like putting it away.
Yeah.
it's in the attic now.
Yeah. Yeah, I think that's a really good point too.
So Ryan, who was on, he had to drop off. I'm going to assume it's his newborn calling for him. But he and I worked for a client one time whose favorite task in the entire world was deleting code. We worked on an enterprise system, a huge, millions of lines of code type system. And we'd find a piece of code that we didn't think was being used, and he'd start the research. And you could tell right away he was never more excited than days when he got to go in and just delete huge portions of code. It was the only technical piece he did on the team because he was the manager. But no one would dare try to take that away from him because he enjoyed doing it so much.
It ties into the previous talk too, because, what better way to manage, LibYears than to delete the lib dependency altogether?
Yep.
The best PRs have 0 lines.
Or net negative, yeah. So I'm assuming you eventually read the book. Like, how long did it take you to get around to it?
I think my mom gave it to me when I was like 14, and I read it when I was 27. So it's short too. It's so It's like a super quick read. Highly recommend it. But I don't know, teenagers are like that.
What's the name of the book again?
Art and Fear.
Thanks.
Yeah, I liked your comment that like going into software was an act of rebellion. I think that's really amusing. And now you've brought it full circle with like you're discovering the art in the software. So
yeah, totally.
All right. Well, we did have some people join late. So, Michael, do you want to introduce yourself and tell us what you do?
Yeah, sure. I'm Michael. I'm based out of Northern Virginia. I'm a software developer. I've been done Python for a long time, probably about 3 years, but I've been doing a lot of Java. And then I've been all over the place, then doing some Drupal work as well. And then, right now I'm doing a bit of Drupal and Python. I'm using an open source solution called Zato. It's an ESB. Zato is Z-A-T-O. It's an ESB that I'm trying to do all sorts of integrations with Drupal sites, with Google Analytics, with some other health information systems, blah, blah, blah. So, I tend to switch between Java, Drupal, and Python. Those are pretty much most of the things that I do, and mainly back-end development, really. I struggle a bit with the front end, but I can go in and hack my way around. That's what that's a bit of me.
Thank you. Ming, do you want to introduce yourself? He may not have a mic hooked up. Let's try. How about Neil?
Hey, hello all. Hey, didn't mean to be lurking out here. I have a grill duty on the back deck, so but really enjoyed both talks, caught most of them, and thank you very much for putting on the meetup. I'm not a dev. I fumble around with a couple languages trying to learn. I'm waving the pom-poms for the geriatric ward, trying to learn new stuff. So anyway, thanks for doing the meetup, okay?
Thanks a lot for coming.
All right.
All right. Well, if there are no other questions, I just want to thank Valerie and Scott again for presenting. I am going to put this recording up on YouTube tomorrow. I'll send a link out to it. We do have a meetup each month. We've been trying to stay on the same Wednesday. So our next one, double checking, I think it's September 23rd. Is our next one. And we're going to have Cassandra Komar is going to talk. She hasn't said what she's going to talk about yet, but I am quite sure it'll be technical on Kubernetes or Docker or something like that, because that's what she does. And I am looking for another speaker. So if anybody has anybody in mind, I'd love to have another speaker come out for September. I'm always looking for more speakers. We have like I said, we're trying to do one meetup a month and try to do 2 speakers at each meetup. So I'm happy to take any suggestions. I think that's about it. So thank you again, Valerie. Thank you again, Scott. Really appreciate you talking. Anybody else? All right.
Yeah, Skirt. Thanks, everybody. I just want to say the same thing. Thank you for putting that together. It was hard to put these presentations together.
All right. Well, thanks, everyone. Have a good night.
Thank you.
Yep. Bye, Seymour.
Bye.
And Valerie, I think I met you at Ruby Nation ages ago.
Yes, that's correct.
Okay. I thought I remembered you from there.
I think I have a Corgibytes sticker on my old laptop.
That's awesome. If you want another one, let me know.
I might. I have a new laptop now.